Hi everybody, welcome to class. Today we're going to talk about bodies. Here you see an example of a blanket octopus. So one of the most interesting kind of sexually dimorphic animals is the blanket octopus, and we'll kind of use them as an example throughout this lecture. So here's our discussion questions. We're going to be talking about everything from dimorphism to how we define sex differences as real, um, hormones, genes, biological traits, what's immutable or mutable, and brain plasticity and all of those things. So it's actually a really interesting topic and chapter. So, what is sexual dimorphism? So, sexual dimorphism is when there's a large average difference between males and females. Um, so, we like to, in our culture, talk about how men and women are extremely different. But when we look at average differences, we don't see any really significant average differences between men and women, at least in the physical regard, especially when we compare those types of physical differences to ones that we see in the animal kingdom. So one of the examples here is of a female blanket octopus. They're about 40 times larger than the male. They're so much bigger than the male octopus that for many, many years, scientists actually couldn't find the male blanket octopus, and they thought that there essentially were not any male blanket octopus, and that's because they're about the size of your pinky nail, the males are, whereas the females are 2 to 3 centimeters long. They're huge. And if you ever get to see a picture of one in real life or see one in real life, they're absolutely beautiful animals because they have this like iridescent quality to them. So they're gorgeous animals. And what's cool about them, what's quite interesting, is the male octopus detaches his penis and then gives it or attaches it to the female octopus, and she may accept or reject his offer. Once he does that, though, he dies. That's kind of the end. Let's hope that he gives it to a female octopus that accepted his offer. The anglerfish is similar, also highly sexually dimorphic. The one that we all know of, the big scary one with the antenna with the light that comes out in front of them, those are only female angler fish, and they're the ones that hunt in the deep, deep sea in the dark, and they have like a little antenna light. And when animals come and inspect the little antenna light, they essentially eat them. Uh, the males, though, actually can't eat. They have no stomach, no intestines. The only way that they can survive is by finding a female anglerfish and attaching, basically biting her and attaching to her. And that's how he gets his nutrition. He would starve if he didn't do that. And so once he does that, he starts to integrate into her body. So first his mouth will dissolve, and then his face will dissolve, and then the rest of his body will dissolve into her until he's just a set of testicles attached to the female. Um, and then she may have multiple sets of males attached to her or male testicles attached to her. So these two animals would be considered highly sexually dimorphic. And when you compare them to human beings, you can start to see how we're not quite as sexually dimorphic as that. So when we talk about ourselves, or even when we're doing scientific study on animals, we need to figure out what is the appropriate way to start asking the questions, right? Because we have our set of ideology, and then we have science. And so science comes with a set of rules, methods, and criteria to inform us and to allow us to take an unbiased approach. And so, in terms of this particular research, what we need to do is we need to start with defining male and female. Um, Conceptualization of concepts like what we mean by a difference and what we mean by male and female are extremely important. Based on the one of the earlier readings, I believe chapter 1, the book talks about how just the definition of male and female is quite a diverse category, because this includes cisgendered people, it includes trans people, and it includes intersex people. So if you're admitting people, for example, trans people and intersex people, from your research, you need to specifically state that. We know that they're not being quantified or measured or observed within the study. It's not to say that you can't, but it needs to be clear who's included, what type of uh, category you're using, how you're using that category, and who's being included and excluded by that category. Also, our operationalization becomes really important as well, because when we talk about something like a difference, right, we're talking about an average or typical difference between two groups when we're doing this type of scientific research, not about a difference between one particular selected male bodied person and one particular selected female bodied person, as we would often do if we were doing armchair theory and trying to prove our point or make a case to support a hypothesis that we have a preconceived notion that's correct, right? We might use an example of one or an n of one. Whereas in terms of what would be considered an appropriate scientific method, they're going to use a larger sample size, much larger than one. And then you also want to ask who's asking and why. So what we know is that there have been some real non-neutral efforts being proposed as scientifically made or scientific evidence to prove that women are inferior to men. We have been or had the presumption that women are inferior to men for many, many generations. And we see the scientific history going back to the 1600s, where they started with that notion, the ideology that women are inferior. And so starting from that biased standpoint, all male scientific groups essentially propose scientific evidence, much of it derived from religious texts, that supported the common ideology of the time. And that was that men and women are different and that women are inferior in a variety of different ways, which then supports the idea that women should be kept out of certain types of environments or kept out of certain types of educational systems, science, for example, which is why it was conducted by all men. Today, we're less likely to do that. And so when we're asking questions scientifically, we do realize that it's slightly more complicated, right? So we know we need to have a sound methods design. We know that we need to be clear about our measurements, our conceptualization, and operationalization, right? So we need to be forthright about how we're designing our studies. We need to be forthright about how we are conceptualizing things like men and women, how we're conceptualizing a typical difference or an average difference, and how we are operationalizing what we're using to measure, observe, measure, quantify what we're looking at. So the text, Lisa Wade and Farie's text, they use the Zell study. The Zell study is actually a pretty large study. So it was a meta-analysis. She talks about it as having 21,000 individual studies, meaning there were 21,000, they pulled together 21,000 different scientific studies that people did, mostly in psychology. And they did one study, what is called a meta-analysis, with all of those studies together. That meant that there was a total sample size of over 12 million cases. or 12 million individuals that were included within that sample size. Because of that, the findings are fairly well generalizable, meaning we can generalize it to the larger population because it's a huge sample size, right? And so what they found was that or not approximately, 39% of the variables in each category that they measured were negligible or non-existent. 46% of the variables in each category were defined as small. 12% were defined as medium. 2% were defined as large, and 1% was defined as very large. So the 2% that were defined as large were frequency of masturbation and approval of casual sex. The 1% that was defined as very large is sexual identity and sexual object choice, meaning male-bodied people were more likely to be interested in female-bodied people sexually, and female-bodied people were more likely to be interested in male-bodied people sexually. That's where we're the most sexually dimorphic. So we explain how we're defining as real. So how do we define as real for the purposes of this research and for the purposes of this book? So sex differences are real if they can be measured, if they can be observed in all or most contemporary or historical societies. Sex differences are real if they're biological, and sex differences are real if they're biological and immutable. So there's 4 ways in which sex differences are defined as real according to Wade and Ferrari. So when we talk about sex differences as real, they're real if we can measure them. So when we talk about measurement, it's an observed difference. So observed different sex differences mean that we can observe, measure, and quantify what we're looking at, what we're doing research on, right? They also need to not be easily changed, meaning not easily primed or socialized into an opposite direction. We often learn differences through socialization and priming. So actually, what we know is that a lot of the things that we consider to be gender differences, if you're simply reminded of a stereotype prior to taking a test, for example, you can be easily influenced in one direction or another in terms of changing the outcome of that test. So a good example of that was a test that was done with males and females where they primed the male and female population that was taking this test on empathy, that men were less empathetic than women. And then in some cases, they didn't prime the population. They didn't remind people that men were less empathetic than women. And what they found was that when they primed just by 1 or 2 sentences prior to the test, men scored much lower on their empathy test than women. But when they didn't prime men and women for men being less empathetic, they tested very similar on their empathy scores. So that's a good example of how you can influence a measurable, what would appear to be a measurable trait, even though you can observe and measure and quantify it, it's too easily manipulated through priming. Math testing is also a good example of this. I put up the Teen Talk Barbie. So this came out in the 80s. So this is when I was a little kid. And Teen Talk Barbie, I think she's gotten a kind of a new, she's come back into the media for what she was saying, because now we look at it as highly inappropriate. She would say, math class is tough. Who do you have a crush on? And this was sold to young girls, right? Priming us as young girls to know that math was difficult and that we should not be performing well in math. So let's talk a little bit about that, right? Because sex differences are considered to be real if they're observed in all or most contemporary and historical cultures, right? And so as Americans, we tend to think, well, math, right? Men tend to do better on math. Well, what we don't realize is we've been socialized to believe men do better on math. And it's not necessarily a true and observable clear trait. So we still believe girls today are not as good at math as boys are. But in the 1990s, when Barbie was telling us young girls that math class is tough and do you have a crush and something about parties, I don't remember what it was, um, girls were definitely struggling more than boys in math. And they were not testing as well in math, and you didn't see very many high achievers in math, right? So in the 1980s, boy geniuses outnumbered girls by 13 to 1. But by now, today, boy geniuses outnumber girls only by 3 to 1. So we're only talking like a 40, 50-year difference. What's going on here? Why such a change, such a dramatic change? Well, we know um, in in addition to the priming and socialization of young girls to not be as good at math, we're less likely to identify a girl as having a good math ability or a high achieving math ability or being a genius. So even if a girl has that capability, she's less likely to be tested and identified. Also, girls are simply just given less opportunity. Why do we see so many girls performing at similar or higher rates today than in the 80s? We know it's mostly because girls are just taking math classes at a higher rate today. So, what changed the gap in performance? Girls were given the opportunity to take math classes, whereas girls simply weren't taking the math classes or given the opportunity to take math classes at the same rate that boys were given the opportunity in the 1980s. And that significantly changed the outcomes in terms of top performers. If we just look at the top 1% of math achievers, and we look at it by different categories, we could see not only the change over time, but the change based on what we would call culture. So you have to think of culture as like one culture to another or one country to another, but you can also think of culture as one class to another. So people who are wealthy, or different racial groups or ethnic groups, right? So cultures change based on time and place and culture, meaning um, race, class, that type of thing. So looking at the top 1% of math achievers today, white boys still outperform white girls, but Asian girls outperform those same white boys. And in Iceland, Thailand, and the United Kingdom, girls dominate the top 1%. So, what is the difference? What's creating the difference? It has to do with socialization and opportunity more than some inherent genetic trait. Um, in addition to that, how you test and how you construct the hypothesis actually really matters significantly. If you test genius math levels, boys outperform girls. But if you test for poor performance, boys are still outperforming girls. What am I saying there? What does that mean? You see more boys at both ends of the spectrum. So you tend to see more genius boys, but you also tend to see more boys with intellectual disabilities as well. So they tend to have more variation, and it may potentially have something to do with the XY chromosome, and that's because The Y chromosome is not necessarily believed to carry a lot of genetic information. So if there's some kind of problem with the X chromosome, you don't have a backup like with girls. You have an additional X chromosome to give that backup of information. So you tend to see more boys at that lower end of the level, or more genetic issues, more recessive genes tend to occur with boys. That's why boys also more likely to be colorblind, those types of things. None of these differences, though, tend to be consistent across countries, groups, or over time. So we don't consider them to be a truly real difference because they don't stand the test of time, and they don't stay consistent across culture. We do, however, see a really high correlation between gender inequality and math ability. What does that mean? In any culture where the culture has a predominant ideology that men are inherently better than women, or better at math, better at science, more intelligent, just better overall than women, you tend to see higher levels of math ability in those cultures. So you see more of a difference between male and female performance in those cultures. So it's more correlated to the ideology of the culture and class or in inequality. Sex differences are real if they're biological. So, what are biological differences? When we talk about biological differences, we're talking about our hormones, our brains, our brain morphology, our genetics, right? So, all of us have a set of genes. We know pretty much what genes do. They're the building blocks, they're the instructions for building and maintaining our physical bodies, right? And we know that women tend to have, or female bodied people tend to have, two X chromosomes, and male bodied people tend to have an X and a Y. There are other variations, by the way, like XXY, Klinefelter syndrome. You can have other variations of those chromosomes, right? And that's where you may end up getting somebody who is considered intersex. But genes are your building blocks. Every single one of us has a unique set of genes. We would call that our genotype. And the expression that our unique set of genes gives us, the way you look, the way you talk, the way you act, your physical traits, your behavioral traits, that's your phenotype. So we each have, everybody has genes, everybody has a unique set of genotypes that then is expressed through your phenotype. Um, and hormones essentially act as the messengers that carry instructions to the rest of the body. And that's also another way in which you can end up being intersexed. One of the most common ways to be an intersexed person is that essentially your body doesn't recognize the hormones that are telling it to go from female bodied to male bodied in utero. And so you stay female bodied, and that's a type of intersex person. But we know, or Zell would say, that the differences are biologically real, if they are phenotypes that are produced by our genes. And so a great example of that is the blanket octopus. I thought I got a good picture of it here. So here's the female. I mean, you can see her beautiful colors here, and then you could see kind of a picture of the male there. And again, he's about the size of your pinky nail, and she's well, 2.5 to 2 to 3 meters. She's like the size of a length of a vehicle, I guess you could say, if I'm doing the math right. So she's huge, and he's absolutely tiny. And that is a very good expression of how your genes can give you a real difference, right? Being male bodied or female bodied. There are other ways in which your genetics can contribute to gender differences. Specifically for the purposes of this reading, we talk about sex-linked traits, sex-limited genes, and sex-influenced genes. So sex-linked traits are the traits that are tied to whether you're genetically male or female bodied. So your genetics XX and XY chromosomes. So that a good example of that is your primary sexual organs, right? So those are very sex linked traits. Sex limited genes are the ones that are only expressed if they're in a male body or a female body. For example, only a female bodied person would be able to breastfeed. That's a sex limited gene, so it's limited to one sex. A sex influenced gene, on the other hand, is one that depends on whether or not you're male or female bodied, but it's more influenced by the hormonal environment. So, balding in men is a good example of this. So, balding is because of high testosterone. But since women and men have testosterone, women can actually have high testosterone, enough high testosterone to actually create balding in women as well. So while that's a sex influence trait, because we're more likely to see it in men or male bodied people, it can be expressed in a female bodied person. So another way in which we want, which the science says or defines traits as real, is whether or not those traits are mutable or immutable. So to be mutable means that the trait can be changed or influenced based on external um, the environment, right? Your external environment. So our brains are able and our bodies are able to process things like sound and sight and touch, right? And we're responsive. Our bodies are responsive to external stimuli. And our bodies actually do shift or change based on that external stimuli. And in actuality, a lot of our biological traits are mutable. They can change based on our environment in ways that we probably never even realized. So a good example of that is visual spatial ability. Um, we know that if you practice visual spatial things, like playing Tetris, you're going to be better at it, right? So, or if you happen to be blind, your brain may adapt in other ways to compensate for not being able to see. So you might have a more sensitive sense of hearing or touch or awareness in other aspects. And we do know that even things like marathon records have changed over time. So um, we've always said, okay, men are faster than women, but we've seen both men and women get faster over time. So a woman today who has the more opportunity to be active as a runner, an athlete, who is told that they can be athletic, that they can do marathons, their marathon times have gotten much faster. They would be faster than a man 100 years ago. So we see both of them come faster and their times are getting closer and closer together in terms of men aren't slowing down, but women are kind of catching up to men. And we even see things like estrogen and testosterone change based on our social environment. This one I find very fascinating because um, based on the activities that you do, the people that you're around, what you're interested in, it can change your estrogen and testosterone level. And your estrogen and testosterone level fluctuates over your own lifetime. It fluctuates based on your environment. It fluctuates based on the time, the time of month you are in a cycle for both men and women. So it is very mutable as well. When something's not mutable, that means that the environment can't change it. So, like your height, for example, you're not going to be able to change your height because you change your social environment or you exercise more. That's an immutable characteristic. So, both men and women have testosterone and estrogen. We often mostly focus on testosterone because we do tend to focus on male bodied people. We tend to focus on things that we consider to be more valuable, and that tends to be male centric. So you do tend to see more research on testosterone, more concern with testosterone for men. A good example of that is if you're low testosterone and you're a man and you go to the doctor, they will almost immediately give you testosterone to help you bring your levels back up to normal. But all women go through lowering levels of estrogen and could use assistance with additional estrogen as they go through perimenopause and menopause as they get older. And it's actually kind of rare for women to be able to get access to supplemental estrogen, even though it's available, and we know the causes are are really good for women, and doctors are often not very knowledgeable about the benefits of estrogen as well, or the problems that women face and how they're connected to estrogen. What hormones are our body's mechanism for changing, for communicating. They literally take the signals to our body to tell our body what we need to do. And they influence absolutely everything about our life. From prior to being born, it tells our body whether we should be male bodied or female bodied. Um, it influences our mood, it influences our appetite, it influences our reproductive cycles, it influences our sexual activity. It influences so much about our lives, and yet we often don't quite understand it or know enough about it. And we tend to be, sometimes slightly ignorant about what testosterone and estrogen do. Now, I have a question for you. Who would you think is more sensitive to estrogen, and who would you think is more sensitive to testosterone? Most of us assume that testosterone is a male bodied hormone, or it's a hormone for the men's hormone, right? And estrogen is a female hormone. All human beings have a balance of testosterone and estrogen. Uh, However, women tend to be more sensitive to testosterone, and men tend to be more sensitive to estrogen. So, actually, men need less estrogen in their body to have a reaction to it, and women need less testosterone in their body to have a reaction to it. And it can impact you in ways that you probably never really realized. So here's a good example of whether you might actually kind of have an idea as to whether you have a high level of testosterone in your body or not, being either male or female. People with either very high levels of testosterone or very low levels of testosterone are associated with poor visual spatial ability. Meaning, if you have a moderate level of testosterone um, as a human being, you're probably going to have better visual spatial abilities. However, if you're a female bodied person, that would be considered a high level of testosterone. And if you're a male bodied person, that would be considered a low level of testosterone. So, women with high levels of testosterone tend to be better at visual spatial ability, mental rotation. Think Tetris, or uh, what's another good example? Tetris, engineering, designing, those kinds of things. That's mental rotation and visual spatial ability. Men with low levels of testosterone tend to have better visual spatial ability. So it's those people in the middle. So if you are a man with high testosterone or a woman with low testosterone, you're unlikely to have very good visual spatial ability. It also affects things like our sex drive. It triggers ovulation. Um, and it even influences how you interact with other people, and how the world around you affects your levels of testosterone. So we have this idea that men and women have different strengths and weaknesses, that our brains are different, and we have different strengths and weaknesses. We have not seen any clear evidence to that, and so that's a theory, a hypothesis that has not been supported. Let's talk a little bit about sex-linked traits. So this is the fourth one. Sex differences are real if they're biological and immutable. I have an example here. I have a couple parrots, and so these are another highly dimorphic animal. The green one is the male, and the red one's the female. They're so sexually dimorphic that people thought that they were two different parrot species. That's how dimorphic they are. So they're an extremely dimorphic, sexually dimorphic animal. And their dimorphism is linked to their genetics, and it's the genetics connected to whether, as an animal, they're male-bodied or female-bodied. Only the males are green, and only the females are colorful purple and red. They're really pretty. Both of them are really pretty. And human beings as well have some genetic differences based on being male-bodied or female. We do know men's and women's brains have different ratios of white and gray matter. On average, women's brains weigh a little bit less than men's brains, and men typically have stronger and denser bones than women do. All of these are immutable sex differences, meaning you can't change the density of your bones, you can't change the weight of your brain, and you can't change the ratio of your white and gray matter based on external environment, like playing Tetris. What we often dismiss is that we tend to make this kind of culture versus nature versus nurture environment, right? So sometimes you hear people say, well, it's all nature, right? That everything is biological, or I'm sorry, everything exists independently. It is biological and exists independently of external influences, meaning that we are solely based on whether our genes, and no amount of priming or socialization actually matters, that it's all about nature, and that human beings are different or dimorphic based on that. The culture argument is that it's all purely a product of socialization, and you could socialize somebody into a specific gender or behavior, and neither of those things are true. The truth is that nature and nurture are essentially inseparable. They work together to produce the sex differences that we see. So nothing is completely 100% nature or completely 100% nurture. Some of the cool things that we see with that connection of nature to nurture include things like the hormonal feedback loops and brain plasticity. So, hormonal feedback loop is our hormones influence the way we act, and then the way we act influences who we're around, our behavior, our environment, and then that environment then again influences our behavior. And we often think of women as having like um, PMS. We think of women as having the ones that have to deal with hormonal changes or having fluctuations in terms of their levels of estrogen, right? So we all often think about women's cycles and that solely being connected to women. Men have their own version of this, so men have those hormonal cycles as well. They're at a faster rate than women, and so men do experience levels of change in mood, in being mood connected to their hormones, and body changes connected to their hormones as well. It just doesn't come at that kind of 28-day cycle, and it's not as obvious to most of us as it is for women. and it's not gotten the same type of attention. But they do absolutely experience those fluctuations in their bodies, as well as their bodies respond to stimuli. For a man, his estrogen level will increase dramatically when he gets married, when he's around more women, when he has a baby. His estrogen level will increase dramatically when men have babies. And the more he holds his baby and he's around his baby, the higher his estrogen levels will get. And the more he responds to his children and interacts with his family, the more that interaction is also going to influence his body and his hormone levels. Our brain, our body, our hormones have a lifelong ability to continue to adapt and continue to change based on stimuli. That is what brain plasticity is, right? We have a lifelong ability to respond to our environment. So if we're around very aggressive people, if we're doing MMA fighting, whether we're male or female, if we're around that type of environment, our testosterone is going to increase. But if we're around children, if we're around babies, if we are surrounded by people with higher levels of estrogen, our estrogen levels are going to increase. And that doesn't matter whether you're male or female. That'll happen regardless of your body. So, as humans, we're not actually a sexually dimorphic species. We tend to be very similar in a lot of our traits, our physical traits, and our behaviors. There are animals out there that have large average differences or typical differences. The elephant seal, lions, of course, my favorite, the blanket octopus, bonobo or certain type of, I believe it's bonobo chimps, certain types of orangutans, right, all have sexual dimorphism that are expressed through their body types and also their behavior in much more of an average typical difference than you would see with human beings. But for human beings, we do have sexual dimorphism. Do you remember the two ways in which we as human beings are highly sexually dimorphic? Okay, well, that's all of it. So, one more picture of the blanket octopus, and I hope you enjoyed the lecture and you made it all the way through. Congratulations. And don't forget to answer the discussion questions and have a wonderful day.